3 power minus x plus 2 divided by 2 log 3. So that would be the recipe if you know your standard form of the integral is really perturbed, is changed by a linear expression actually. Okay, by a linear expression. Then you can apply this algorithm and compute the integral actually. Now this is one of the technique when you are replacing something by replacing the standard form by replacing the f of x by x by a linear expression. What if I replace it by a quadratic expression or a cubic expression actually? Okay. What if I have a kind of a, so I can say so this is a linear expression. What if I put a quadratic expression here actually? What if I replace this x by not a polynomial but say a sine x? What if I replace this x by say e to the x, and then I ask what would be the integral? So in other words, I'm saying what if I in this integral, the standard form whose antiderivative is known to you, you replace the x by some function of x by some function of x. How to integrate? Okay. How to integrate it? Can I integrate all such expressions? Can I compute above in general? The answer is no and yes. In other words, sometimes yes you can compute. For example, if my g of x is ax plus b, yes I can compute the integral. But if gx, this function that is inside, that has been replaced by x actually, if this function is more complicated, then maybe it would be difficult to integrate such kind of function. But here is the good news. Here is the very good news. That if in a given function f of x dx, you replace x by not ax plus b, not sin x, not cos x, but by another function f of x. Okay? But by another function f of x. Okay. So if by x I replace not ax plus b, not e to the x, not sin x, not cos x, but replace another function, then can I solve such integral? The answer is it depends. If with this expression, such expression, if with such expression, the derivative of the function that you have inside the, this outer function, if its derivative is present here, then you can integrate it. Then you can integrate it. So in other words, if you have a composition of the function, so in other words, if in the standard integral you replace x by a g of x, and with this expression its derivative is multiplied, then you can solve this integral actually. You can solve this integral by substitution. And how you are going to do it? So let's do it actually. So what are you going to do? So let's assume t whatever is inside. the function actually. So let t equal to what do we call g of x. Now what would be dt by dx? dt by dx will become g prime of x. Okay, and hence you can say your dt will become g prime of x and dx. Aha! Now you can see that why you need a derivative actually of this inside function g. Because with this substitution and this substitution, your integral will be converted into a very standard form. And what would be this form? That replace g of x by t, replace g prime of x times d of x by dt, then I know how to integrate it. And what would be the integral of this? So say the capital F is the antiderivative, okay, of small f plus constant, what do we call c. And what are you going to do? So if I have f of t, and now we're going to replace f by t by the substitution g of x, dx plus c. So this is really the answer of this integral. Okay, this is really the answer of this integral. Okay. So, what you have such kind of, what is this kind of a situation? That in the given function f of x dx, by x, you are replacing x by another function g of x. Then its derivative must be multiplied here. So if the derivative is multiplied here, then making these two substitution will solve the problem. Okay? So let's see some examples of it. Okay? Apparently, complicated looking functions would be easily, for example, solved. So imagine I have e to the x dx. But in the place of x, if I, for example, replace sine x, so this is like composing e with sine x, then can I integrate this? The answer is yes, if the function with which you are composing e, okay, its derivative must be there. So if there is a sine x, cosine x, yes, you can integrate. Yes, I can integrate. Okay. In other words, I can treat this function as a composition of two functions. So the f of x is e to the x, and the g of x is sine x. So what would be f composition g of x? So f composition g of x is really e to the g of x, which is e to the sine x. You should be able to spot actually such kind of functions quickly. So you have e to the sine x, okay, x is replaced by another function sine x whose derivative is there. I can have another example. For example, I can say I have, say, e to the x square. So this time the function e is composed with the square function. So the question is, can I integrate it? The answer is its derivative is multiplied here actually. So if you find its derivative multiplied with the composition of the, the composition with the function g, yes, you can solve it. What would be another form, for example, for it? So I know that I have sine x dx. But if by this x I replace e to the x, in other words, by x I replaced a function of x, then can I integrate it? The answer is yes, you can, if the function, this e to the x, its derivative is multiplied at. So if its derivative is multiplied, yes, you can easily calculate this. Okay, I'm going to do the calculation, don't worry. But I just want to make you sure that this expression should make sense to you. So for example, I know that I have function, say square root of x, but instead of having square root of x, say for example I have x cubed plus x square plus 1. Question, can I integrate it? The answer is, so this is like composition of square root function with g of x is x cubed plus x square plus 1. You can derivate it if, you can integrate it if the derivative of the g is multiplied with it. The derivative of the g is multiplied with it. Okay, you can do it. And how to solve all such problems? The same technique would work. You can do it in the same number of steps. So let's give this g function a name, x cubed plus x square plus 1. So the dt by dx will become 3x square plus 2x. So I can say that my dt is really 3x square plus 2x dx. And once you have it, then you can simplify this problem. This will become what? Square root of t. This entire guy will become dt. So it really comes in a really standard form. So this is like you have t1 half dt. And I know how to integrate t1 half. So it's going to be t1 half plus 1 and 1 half plus 1 plus c. So it's going to be t 3 half divided by 3 half, or I can say multiplied by 2/3 plus c, and then on the place of t replace whatever is really x cubed plus x square plus 1 power 3 half times 2/3 plus c. So this is the integral of this function. So the same steps would work. You can apply this technique to any problem. So for example, I mean, think about it. If I have given you this problem, you know, directly to solve and said you to guess the function whose derivative is this, or what would be the antiderivative of this function, it would be a nightmare to guess actually. But thanks to the substitution rule, that it works. So you have sine e to the x times e to the x dx. So I'm saying sine function is composed with e to the x. So my g of x is really e to the x. So my dt would be e to the x dx. Okay? So this will become what? This will become sine t, and this will become what do you call dt. So this substitution, if you have such form, this substitution is really miraculous actually. It can just radically convert your complicated integral into one of such kind of integrals actually. Okay, such kind of integrals. So this is going to be what? Negative cosine t plus constant, or you know, replace t by this, and the cosine t is going to be e to the x plus constant t. So this is what really is the answer of this integral. Okay. Why I took you to the formula? Because I want to make sure that you really understand the essence of the substitution method. Okay. The formula that I gave you, okay, is really the essence of the substitution method. So the substitution techniques is this. Okay, if you have to keep it in your head, always think, okay, if I have a function f of x dx of this type, and I replace x by say g of x and dx, then the question is, can I integrate such kind of function? The answer is yes, if the derivative is multiplied. If the derivative is multiplied, then you can do it. Okay. Now here is a little caveat. Imagine I say that, okay, I have here x square plus maybe 2x square plus 3, and here, so it's like a square root function composed with 2x square plus 3, and I have x dx here. Okay? I have x dx here. Now you're going to see a little caveat. Caveat is this, not trouble, that okay, if I take this function as g of x, what is the derivative of it? So it's going to be 4x. Now you have x, but you don't have 4. So you are short with a constant, not a variable. So you have to keep in mind, you are short with a constant. So if you are short with a constant, you can always multiply and divide that constant. So in other words, if this is 2x square plus 3, its derivative outside should have a 4 with it. So let's multiply 4 inside and outside, because I know that I can take this 4 outside of the integral, and 4 will cancel out and nothing would change it. And apply the same technique. That okay, my t is 2x square plus 3, my dt is 4x dx, then you know how to do it actually, that this will become a square root of t dt, and then integrate it like that, and then substitute back, actually you're going to get it. So if you are short by a number, you can always add and multiply and what do you call, divide it. Okay? You can always multiply and divide. And you can see that you can solve a hell lot of questions like this with such kind of problems actually. Okay? Such kind of problems. So imagine I have a function like x dx divided by square root of 4x square minus 1. And I want to integrate it. Again, can I see this function as the composition? I mean, the rough idea is that yes, the square root of a function is composed with g of x. It's not really square root of function, it's the 1 over square root of x composed with 4x square minus 1. Okay? But you can get a guess that okay, something that is in the square root, that might play a role of g of x. So what would be the derivative of this function 4x square minus 1? So it's going to be 8x. So we should have 8x dx. The trouble is you have x dx, not 8x. And we just saw that we can divide and multiply that 8. Okay. So this 8 is like a constant, you can pull it out of integral and 8 will cancel out, so you're not adding anything new into it. And then take t to be 4x square minus 1. Then dt is going to be then 8x, and your integral will be converted into dt divided by the square root of t. Or you can say this would be 1 over 8 dt divided by t1 half. Or you can say this would be 1 over 8 t power negative 1 half and dt. Okay? Because this is what the standard form is, that okay, you have some variable power n actually. and then you can do, so you're going to have t minus 1/2 plus 1/2, so it's going to be 1/2 divided by 1/2 plus constant c. So this will become 2 by 1, so this will become 1/4, and replace t by 4x square minus 1 power 1/2 plus constant c actually. So this is what is really the integral of it. Okay? Integral of it. Here is that. Interesting. I know the integral of secant square x dx is tangent x. That's constant. But if I flip actually and I say what is the integral of tangent x dx? Can you guess the formula? Wait, pause the video for a minute or a few seconds and try to guess a formula for the tangent x. Question is, you can. So how to deal with it? So we can do one thing, that I have, for example, this sin x divided by cos x and dx. So since the tangent is sin x or cos x, so I can write it in this manner actually. Okay? Now what should I do? So I have to do substitution. So this is like, okay, so interestingly, the derivative of cos is sine and sine is cos actually. So what substitution should I make? Okay. So you have to always consider, because if you see g prime of x is in product with dx in the formula. Okay? It's in the product with the formula. It's not in the division of the formula. It's not like that. Okay? So the good guess for the g is that, okay, like this is like your g prime. So this means that this must be my g actually. Now can I see this function as a composition? Answer is yes. You can see also this is a composition, that 1 over x has been composed with cosine x. So if my f of x is 1 over x and my g of x is cosine x, then f of g of x is going to be 1 over cosine x. Okay. Anyway. So if I make a substitution t, which is g of x is cosine x, and dt, so don't try to always memorize the results. I would always say this is, so while solving this exercise, this is the best thing that you have actually when you have to integrate. Always try to spot what is f, what is g, and what is g prime. If you try to do the direct substitution without using formula, okay, maybe you can memorize, the solutions to the problem, but you will not make sense of it actually. So this is the principle for the exercise that you are doing. Okay. So if you do the dt, one thing I must say that there is an assumption on the g that g must be differentiable. So if g is a kind of a function whose you can't find its derivative, then this formula wouldn't work actually. So that's one caveat. So the dt by dx is going to be negative sine x. So you can say that dt is a negative sine x dx, or you can say negative dt is sine x dx. So with this substitution, this integral will become negative dt by t. So if you wish, you can take this negative outside, and the derivative of this is going to be negative log of absolute of t plus constant c. Okay? This is what that you're going to get. So negative log of absolute of t is going to, t is cosine x, or you can do that, okay, log of cosine x absolute and power minus 1 plus c. Okay? Because in log, whatever you have in coefficients, you can make it in power actually. So this, you can write this as, 1 over cos x and its absolute. So really 1 over cos x is going to become secant x actually. So the integral of the log x is log secant x plus a constant c. So this is what is really the integral of tangent x, log secant x plus constant c. There is no way that you can guess this function without making your hands dirty in, what do you call this, this result. Okay? Now let's do some definite integration. Let's do some definite, all of these integrals are definite. So what if you have a similar kind of a problem, but in which the limits are given to you? Okay? Limits are given. So for example, if you happen to be given 0 to 4 and the square root of say 2x plus 1 and dx. So how to solve such problems? Let me give a generic picture first. So what you're going to do, if you have f of g of x and multiplied with g prime of x dx, and then you need to integrate it from a to b, then we know how to solve it. So you have to make the substitution. So the t is g of x, the dt will become g prime of x and dx. The integral will become f of t and dt. Question, shall I write a to b? The answer is no. A to b is a limit on x. It's not limit on g of x. So what should I write here actually? So in order to put the correct limits, what you need to do, take your substitution, take your lower constant and substitute it on the place of x actually. So your lower limit is going to be g of a, okay, g of a when x is a, and the upper limit is going to be g of b when x is b actually. So when you x substitute b, the t is going to be g of b. So the integral is going to be really g of a to g of b. And now these are two constants, don't have to worry about them. So what should I do? Now you need to make the substitution. What will the integral of small f is going to be capital F evaluated at t, and in that you need to put the limit g of a to g of b. So the outcome is going to be f of g of b minus f of g of a. So this is what really is the value of the integral actually. Okay. So when you are solving a generic problem, treat this as a recipe actually. So this is not just a proof or something like that. So it's a recipe. So for example, if you want to apply this recipe on this, 0 to 4 and square root of 2x plus 1 and dx. So it's a definite integral now for how to do it. So again, you have like, okay, this g of x is like t 2x plus 1. When your g of x is linear, don't worry about it. if it is, something other than linear actually, like sine x, cos x, x square or something, then you have to always worry that whether there is a derivative or not. What would be the derivative?